Okay, guys, so this is section 7.3, part 1B. So we should finish it up. We got 3 more problems, and then we'll have the part 1 done. So this one is pretty similar to the ones on part A, and then the next 2 are going to be a little bit different. So let's take a look. Y equals, this one's probably going to require some type of calculator. We want to graph 2e to the negative x squared. Okay, and then y equals 0, x equals 0, and x equals 2. And then we're going about the y-axis. We're still doing y-axis, so part 2 we'll be going around then the x-axis, maybe taking it off of the axes altogether as well. All right, so this one we're probably going to want to graph this. So 2e caret negative x squared. I should have had that typed in. Sorry about that, guys. We get this little, I don't know if you can see it very well, but it's a little bump. Okay. And we only want that bump. We want it when y is greater than or equal to 0 and x is equal to 0. That's cutting all that off. So even though it's a whole bump here, we want when x is 0, y is 0, which when in doubt, we're restricting it always. This stuff is kind of always trying to restrict it to the first quadrant, okay? We're going to over-exaggerate this bump a little bit. So this bump kind of goes like this. It never hits here, but we know that we're going to stop it when x is 2. Okay. So that's what we're going around. It's actually a little bit more like of a bell. Like if this is going on, it would kind of go off more as a bell like that, but we're stopping it at 2. Okay. Let's see what else. Okay, so now if we swing that around to this side, right, now that side actually looks better. Let me redraw it. It kind of goes a bell like this and a bell like this. That looks better. And then we're stopping it at 2. Okay. Let's put in our, so this is 2, let's put in our shell. So we're going to put in our cylindrical shell. Okay. And then we're going to cut it and unroll it. Okay. Thickness, the thickness of the shell is dx. This going up is the height, which is y, and this line going around, that's the 2 pi r. Okay. And this one's maybe, hopefully, a little straightforward. We're going from 0 to 2. We're going from 0 to 2. Okay, because remember, this was a cutoff, and this was a cutoff, so we're going from 0 to 2. So 0 to 2, all right, y, 2 pi r, and then dx. Okay, make sure we can see, okay. All right, so now we don't like y. And what is our radius? Our radius is going across, which is an x distance. So our radius is x. And how do we change this to an x? We go right up here. Okay, so we're going from 0 to 2. The y goes to 2e negative x squared. And then 2 pi, our radius is x. And then dx. And just like that, we've converted everything. So now we're in good shape. We can take these guys out, okay, and we've got 4 pi, we're going from 0 to 2. You can still see this. And what do we have? We've got e to the negative x squared, and then x dx. We got, so this guy's out, this guy's down, this guy's multiplied right out here. We still have the x and the dx. The nice part is we know that the integral of e to the u is e to the u. And that's kind of the key. We've got to make it a u. So we get the luxury, right, of doing u substitution here. So u is equal to negative x squared du then is equal to negative 2x dx. Okay, we want x dx, so we have to divide by negative 2. We haven't done that for a while. So negative 1/2 du is going to take the entire place of x dx. All right, so we got 4 pi 0 to 2. This we can write now as e to the u. And what are we going to put in place of x dx? In place of x dx, we're going to put in negative 1/2 du. Instead of x dx, we're putting in negative 1/2 du. Good. And then this can even pull out. If we want to now pull that out, we could make that then a negative 2, 4 times negative 1/2. So we could do negative 2 pi 0 to 2. And now, since this guy's gone, we moved it out, we just have e to the u du. Okay. So I'm running out of room. Okay, so let me transfer that. Let's see where we are for that. So we've got negative 2 pi. Make sure you can see it. Okay, looks okay. And we're going from 0 to 2, so I'm just going to recopy it. This is just a recopy, e to the u du. Okay. But now we're in good shape. So the integral of e to the u is e to the u. So we got negative 2 pi. Or if we just want to hang on to that, right, we can just kind of hang on to that. The integral of e to the u is e to the u. But just be careful. So that's the integral. Just be careful. Remember, what's wrong with this? These are x's, and that is u. So we have to replace that back. E negative x squared, and now the 0 and the 2 match. Okay. So now we plug in the 2. We get e negative 2 squared, but remember this negative doesn't have anything to do with that x because we're squaring the x and the x is a 2. So this then actually becomes e to the negative 4. That negative, this negative is just kind of tagging along. It's kind of like this guy almost. And then minus, we plug in a 0. We don't care about any really of this other stuff because anything to the 0 power 0 squared is still 0, negative 0 is still 0. So anything to the 0 power is 1. If you want to should we rewrite this? This kind of all this is still a 0, and then anything to the 0 power is 1. Don't forget this guy. This is a good answer. Okay, and it actually is a positive answer. We know visually that it should be a positive answer. You can leave it like that. If you want to get rid of this negative just so that it doesn't look negative, this value the way it is negative, and so that would actually give you a positive. But that's actually the way that they would prefer. If you type that in, you could get a decimal approximation, but that answers what we're looking for. Okay, so now let's change it up just a little bit. We're going to look at y equals x squared and y equals 6x minus 2x squared, and we're going to go about the y-axis. Okay. All right, so this one we know what it looks like, and again, if you just use your calculator, go for it. Okay, this one here, first we might just want to rewrite it. This would be kind of if you don't have a calculator, you just want some practice, things like that. Let me slide it up to make sure in case I go low. If we take out a negative 2, we're left with, oh, actually, hang on, back that up. We might as well take out a negative 2x, right? That makes more sense. We're left with x minus 3. So x equals 0 and x equals 3. Okay. So that just makes it a little bit harder because remember the vertex is halfway in between, so the vertex would be at 1.5, and if you take the time to plug 1.5 in, then you actually get 4.5. Okay, you just do 1.6 times 1.5 minus 2 times 1.5 squared, and that should give you 4.5. Again, this is just if you don't have a calculator. If you have a calculator, just type it in. Okay, that's fine. Okay, so this guy is what? That guy's a regular parabola. Okay, it's opening like this. Okay, and then now this is a parabola. We know that it's opening down. Okay, we know the x-intercepts are 0 and 3. 0 and 3. Okay, and we know the vertex is halfway in between, so 1.5 and then like 4.5. Okay, so this parabola looks like this. Okay, so what are we spinning? We are spinning this guy. Okay, that's what we're rotating around the y-axis, where those two intersect. Okay, all right, so let's draw maybe just that piece. So we're going from, let's see, what would be a good way to do. So we've got this parabola down here, right? And then, so this point is this point here, and then it kind of arcs up that other parabola and then comes down. Okay, and then we've got this, then if it would spin around, then we've got this half to here, and then this guy would match over here, so it would kind of be this portion right there. All right, about as good as we're going to get it. Okay, so now what happens, let's keep this stuff, what happens when we draw in the cylinder this time? Okay, we got a couple things we got to worry about here. When we draw in the cylinder this time, we maybe we could do it here. If we draw in the cylinder here, we're not going all the way down. We only want to go to here. That's where these get a little bit harder. Okay, we don't want to go all the way to the x-axis. We have to stop at that bottom parabola. Okay. Also, we don't want to go to, like, before we use this, because we were going to the x-axis, we got to use these values. But we're not going to the x-axis. We want to go from 0 to where this crosses. That's all the farther we want to go. We don't want to go all the way to 3. So we have to find where they're intersecting, and where they're, let me say it like this, where they're intersecting is not necessarily, it doesn't involve the x-axis, where in the last section it did involve the x-axis. So let's set these guys equal to each other. X squared equals 6x minus 2x squared. So we got to find now the x coordinate of this point. Okay. How do we want to do this? Let's make everything positive. So let's move this over. Let's add a 2x squared. I know that means we'll subtract the 6x, but that's okay. 2x squared and then minus the 6x. So we're going to actually have 3x squared minus 6x, make sure you guys can still see this, okay, equals 0. Okay, so let's factor out a 3x, and then we're left with x minus 2 equals 0. So x is equal to 2, or sorry, x is equal to 0, and then x is equal to 2. Okay, and that makes sense because we knew this was 3, just talking about distance this way. So it makes sense that this distance is shorter than 3. This distance would be shorter than 3. So for the integral, let's see if we can squeeze it on here. We might have to start over, but or just start a new piece of paper, but I think we're okay. So the integral is from 0 to 2. Okay, this is still a cylinder going up and down, so its thickness is still dx. We know we still want everything in terms of dx. Maybe we should have even did that before because these have to match also, right? So now if that's dx, those guys are x's, and we're in good shape. If we cut this, okay, so let's cut this and unroll this. Okay, we know our thickness is still dx, so that's a plus, right? And this is still an x distance. Let me even use another color here. This is still an x distance. The radius is still an x distance. So the circumference of the circle is 2 pi r, but the radius is still x. Okay. This is the one. This is still technically a y distance, but we have to be a little careful. We want to subtract off this distance. We don't want that distance. So we want to to the parabola that's going upside down, and we want to subtract off the parabola that's opening up, because our cylinder stops right here. This may be a bad move, but let's draw in one more. Let's draw in maybe one more cylinder. Yeah, let's try it. What the heck? You only live once, right? Okay, it's only coming down to here. That's it. That's all the farther that cylinder is going. And so I need this. If I just do this parabola that's opening upside down, I'm going to get this whole distance. But what happens if I subtract off the parabola that's opening up? That's this distance, right? If I subtract that off, then I get exactly what I want. Okay. So this is the top parabola, which was the 6x minus 2x squared, and I have to minus the parabola that was opening up, which is x squared. That's going to replace y. All right, so let me get a new piece here. Let's see, can you guys see enough? Maybe, yeah, that might actually work, enough to kind of transfer it. Okay, so let's take all this. We're doing the integral from 0 to 2. We know we want y times 2 pi r, but we know that r is x and dx. Okay, so we kind of already did the r. The y has to be the top parabola minus the bottom parabola, because we're not going to the x-axis. My cylinder does not go down to the x-axis, so I have to subtract off that bottom piece. So this y is going to be replaced with 6x minus 2x squared, and then minus x squared. Okay. It's going to get a little messy here, and then we still have 2 pi x dx. Okay, so let's clean this up, which really, we don't really even need these parentheses because there's nothing to distribute. So we could just write this as 6x minus 2x squared minus x squared. So we can actually change those right away. And we can even, this starts to actually turn out to be okay. We can even collect like terms here. And we get 6x minus 3x squared. 2 pi x dx. Okay, so all of this is just cleaning everything up. I can't, all right, so now let's slide this up. We might need one more piece of paper. We'll see how we're doing. I can't remember. Did we do this in the last one? You don't have to, but you could actually take out a 3 if you wanted. So 2x minus x squared, 2 pi x. All right, and that, oh my God, oh, that's right. Okay, doesn't matter. So we can actually take out, if we wanted to, we could actually take out a 6 pi. We still haven't taken the integral yet. Now we're left with 2x minus x squared, and then we still have x dx. Okay, so now we're in good shape. Distribute that x through. So we have 2x squared minus x to the third dx. And just like that, we've got a fairly basic integral. So a lot of cleanup there, a lot of algebra, and then we still have a lot of algebra to go because we got to plug that in, but at least we get to plug in a 0. But all that was just algebra, all that's just simplifying. Okay. The hardest part now was the y. You had to do one minus the other, and how do you know to do that? Because remember, the graph didn't go down to the x-axis. That's kind of the key there. The graph does not go down to the x-axis. Okay, let's actually take the integral, add 1, divide by the new, so we get 2/3 x to the third, and then add 1, divide by the new, so 1/4 x to the fourth. Okay, we're going from 0 to 2. Don't lose this guy. Now it's a 6 pi. He's worth even more, so don't lose him. All right, so 2/3, 2 cubed, minus 1/4, 2 to the fourth, minus, and then we plug in a 0, so zeros are always nice. We always love you, 0. Okay, then it's just a matter of typing that in. I think that takes us all the way to 4/3. And then we just have to take it times, swing this over, times 6 pi. Oh wow, that turns out pretty nice, doesn't it? That actually gives us 8 pi. Okay. And that is, what is that? That's the volume. If this piece was spun 360, okay, that's the volume of that piece. All right, let's do one last one. Here we go. This one, same thing, probably would help, let me do this, probably would help to have a calculator. So y equals, it's just a parabola, but 5 plus 2x minus x squared, and then the line x plus y equals 5. And one last time about y-axis. Okay, and then that's going to change in part 2. That'll be the change for part 2. Okay, so how do we graph this? Easiest, most efficient way, just go to your calculator. If you want to, we could spend a little bit of time, negative x squared plus 2x plus 5. We know it's going to open down. It's not factorable, so if you really wanted to find these, you would have to do quadratic formula, which isn't out of the, especially if you just change it to a decimal, that's fine. It doesn't have to be, we're not looking for exact values. In fact, to graph it, an exact value probably really isn't going to help. We do know that it's opening down. We could do, let's just spend just a little bit of time and then we'll move on. We could do for the vertex, we could do negative b over 2a. And again, this is all just if you don't have a calculator. Negative b over 2 times a, which is negative 1. And so the vertex is actually, oops, let's not put equals. The vertex is 1. And if I take and plug the 1 in, I actually get 6. So that's not too bad. So the vertex is 1, 6. Okay. And maybe kind of a little bit of a trick, we know it's opening down, is if I plug in a 0 for x, that's going to be the y-intercept. So if I plug in a 0 for x, I know it's hitting it at 5. So that might actually be enough. Otherwise, like I said, if you use your calculator, that's fine. So it's opening down. We know that usually the x-intercepts are always nice to find. This time it was maybe a little bit harder, so I found the y-intercept, which was good enough with all the other information. Okay, and this one's a line. Let's solve it for y, though. Subtract x. So y equals negative x plus 5. Oh, that's kind of interesting. So maybe it was actually kind of nice that I found that 5, because it is actually intersecting right here, 5. All right, and then it's going down 1 over 1, down 1 over 1. So I think it's going like this. I do believe this is hitting up here. You may have to find that x-intercept to know for sure if you're not able to graph it. But one other thing we could do is we kind of need that point anyways, because that is what we're going to be going to, right? We want to know where they intersect. So that would be our integral, our limits. So let's go ahead and set these guys equal to each other. So negative x squared plus 2x plus 5 equals negative x plus 5. And that actually kind of turns out nice, right? Those guys go away. We could add an x to both sides. So we have negative x squared plus 3x equals 0. Why don't we take out a negative x? So we're left with x minus 3 equals 0. And so that means x equals 0 or 3. The negative doesn't really play a part. So this is an x value of 3. So it's 0, which we kind of already knew because of these. We just happened to find the y-intercept for both, and then at 3. Okay, so we actually know we're going from 0 to 3, 0 to 3, and we know that we want it in terms of dx. Okay, so let's draw a picture of this. We might not know that quite yet. All right, let's see. These pictures are killing me, guys. All right, so let's go up and then down, right? So that's that's our parabola, okay. And then that's our line, so that's literally straight. And then let's, now this, I didn't want to mess it up. And then down, and then that's literally all straight, okay. All right, that's not too bad, all things considered. Okay, same thing, okay. How do I know I'm gonna have to do some subtraction with the y? Let's pause for a second. How do I know that I'm going to have to do some subtraction for the y? Because I'm not going down to the x-axis. So when I draw in a cylinder, I'm not going to go down to the x-axis. As soon as I'm not going down to the x-axis, then I know I'm going to have to do some subtraction. I'm going to have to do the top parabola minus the line. Because remember, the top parabola gives me this. And then the line, if I subtract the line off, I'm subtracting all of this, and then what do you know? I've got the orange, okay? But how do I know when I'm going to subtract? When I'm not going down to the x-axis, okay? All right, so if I cut the cylinder, though, let's look at that orange cylinder. If I cut it, my thickness here, I'm trying to make, when I do this, I'm trying to make it a little bit thicker, but my thickness is actually this right here, okay? So I kind of exaggerate and remember that the cylinder has at least a little bit of thickness, and we actually see that thickness right here, okay? So that is this guy going back, dx. This is still y, but remember, I'm going to have to do some subtraction. Maybe we could even just write that. I'm going to have to do some subtraction because I'm not going down to the x-axis. And then this is still 2 pi r. And my r is still, let's throw in one more color, why not? My r is still here over, so that is still x. So this guy is still going to be x, and this one's going to be subtraction. Trying to think. Okay, so let me slide this up. Let's see if we can get it at least here. So we're going from 0 to 3. We know, and we can put it in any order, so we know it's going to be 2 pi x, and then I'm going to put the y, and then dx. Okay, because this is all good to go. This we just usually write at the end. This has to be the subtraction. The top minus the bottom. And this one's kind of nice because you know it's the parabola is on top, line is on the bottom. So you do parabola minus the line. Okay, and actually solving this is a good idea. So parabola minus the line. Okay, so make sure you can still see it. Okay, yep. 0 to 3, 2 pi x, and then here we go. The parabola, x squared plus 2x plus 5. Now here, the last problem we didn't need that, but here we almost need a second set of parentheses. Let's change it to this, because we need this minus the line, which was negative x plus 5. Okay. All of that is y, and then dx. But we're in good shape. Okay, so that's all the new part. Now we're into integral mode, which we're really good at, guys. We got a lot of algebra, but that's it. Okay, so let's go at it. So let me just rewrite it here. We're going from 0 to 3. We got 2 pi x, and then let's rewrite it with these parentheses. Negative x squared plus 2x plus 5. This is just, I'm just recopying it. Oh, not that yet. Shoot. Minus, get rid of that guy. Negative x plus 5. Now we close it off, and then dx. And if you didn't want to do these brackets and you just wanted to distribute right away, that's okay. But this negative has to get to that 5. Okay, so this negative you have to take the time to distribute it. If you do it in your head, that's okay. Okay, so now we're just going to have parentheses, right? Negative x squared plus 2x plus 5. Let's distribute. So now we get plus x and then minus 5. Okay, and we still have this. I just didn't take the time to write it. All right, so how are we doing now? These guys actually cancel, so that's kind of nice. And so we have 2 pi x, we have negative x squared, and then here this will take us to plus 3x. Oh, sorry guys. Okay. Okay, so where are we at? We're almost done here, guys. Let's get rid of the 2 pi if we want just visually. That just helps. We still have this x, so let's distribute that. Negative x to the third plus 3x squared. Okay. Beautiful. Look at that, guys. That looks great. Okay, now we're ready to go. Take the integral, add 1, divide by the new. That's going to take us to x to the fourth, so those match. We catch one little break here, right? And actually, this simplified quite nice, so that was good. Add 1 takes us to x to the third. Instead of doing 3 over 3, we could just leave it as x to the third, right? And then we're going from 0 to 3. Don't lose this guy. My very unofficial parentheses there. And now we're good to go. Plug in the 3, so negative 1/4. 3 to the fourth. You know, if you can just write 81, if you want to just go to your calculator, that's fine. If you want to just write 27, that's fine. 3 cubed minus, and then we still get the luxury of using the zeros. So we're good there. So that's 0 and 0. You don't even have to write both. We're getting pretty good at that. All right, so this gives us, you can just go to your calculator if you however you want to write it now. You're good. You don't have to do that separately. That gives us 27/4. Just don't forget the 2 pi. And so that takes us to 27/2 times pi. All right, and that's our volume. If we spin this around, remember this is 360. If we spin that around 360, that's our volume. Okay, guys, we made it. 7.3 part 1 in the history books.